share the screen. Okay. Let's see. 3.6 question about 3.6. 3.627. Do you have to worry about the domain? That should be something you should know how to do, to find the domain of that. Okay. So differentiate and find the domain. Okay. Do that. So this is 3.627. F of x equals x over 1 minus ln x minus 1. So the derivative bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, which is negative 1 over x minus 1, over 1 minus ln x minus 1 quantity squared. That's essentially it. I wouldn't have you do much more with that. Maybe get rid of the double negative. So 1 minus ln x minus 1 plus x over x minus 1 all over 1 minus ln x minus 1 quantity squared. Okay, for the domain, let's see, I don't want the denominator to be 0. So 1 minus ln x minus 1 equals 0. Move that over 1 equals ln x minus 1. Exponentiate. E equals x minus 1. So x equals e plus 1. Okay, so the domain is all real numbers except for e plus 1. So the domain, all real numbers minus a set consisting of e plus 1. Okay, quick double check. If I plug in e plus 1, ln e 1, yeah, that works. Okay. So that is that one. Same section 23. Okay, I'm on 3.6 now. So if you don't see a section, I'm just doing 3.6. Y equals radical x ln x. Y prime is first times derivative of the second plus second times derivative of the first. 1/2 x to the minus 1/2. So that's going to be radical x over x plus ln x over 2 radical x. But for taking the second derivative, I want to keep it as x to the negative 1/2 plus 1/2 ln x over radical x. Okay, so for y double prime, negative 1/2 x to the negative 3/2 plus 1/2 quotient rule. So bottom times derivative of the top minus top times derivative of the bottom. We just did that. 1/2 x to the negative 1/2 over the bottom squared, which is just x. Okay, so that's radical x times 1 over x minus ln x times 1/2 x to the minus 1/2. Okay, and maybe just clean up the algebra after that. But save time and not do that so I can get some more problems. Okay, 3.69 I've already done, so I won't do that. 17. T of z equals 2 to the z log base 2 of z. Okay, my z's are going to have a mark there, so it's a product rule. So first, 2 to the z times derivative of the second, derivative of log base 2 of z is 1 over z ln 2 plus second function, log base 2 of z times derivative of the first, 2 to the z ln 2. 51 y equals ln x squared plus y squared. Find y prime. dy dx equals 1 over x squared plus y squared. 2x plus 2y dy dx. Multiply both sides by x squared plus y squared. Squared plus y squared. So these cancel out. Just make it look nicer. So x squared. Well, let me do it like this. X squared plus y squared dy dx equals 2x plus 2y dy dx. Move this over with these. So x squared plus y squared minus 2y dy dx equals 2x. Divide both sides by this. Dy dx is equal to 2x over x squared plus y squared minus 2y. Okay, so that is that. Three 3.711a. Let me see what that's about. Yeah, 3.711a. It said that we have square wafers. So the side length is x and the area is x squared. Okay, if that was your question. Okay, it says a square wafer. So once a side is length x, so area is x squared. Somebody was asking about that. 3.711a. Area is x squared. It said that it was a square wafer that looked like that. Okay, so assuming that's all you asked for, that's all I was going to do for 3.711a. Okay, and continuing on, 3.127. Let me see. 3.127 g of q. One plus q to the negative 1 squared. Okay, and yes, even though this is section 1, now that we know everything, you're allowed to do this by the chain rule, which originally you weren't supposed to, but now that we know the chain rule, we'll just do it. So g prime of q is 2 times 1 plus q to the negative 1 to the first power times the derivative of q to the negative 1, which is negative q to the negative 2. And the problem started off with a negative exponent. You can leave it with a negative exponent. So that means I'm done with that. 3.2, number 9. U minus radical u, u plus radical u. So just multiply it out, u squared minus u, which means the derivative is easy, 2u minus 1. Okay, see 3.449. Let's see. .449 limit x approaches pi over 4. 1 minus tangent x sine x minus cosine x. Let's see, if I directly substitute, I get 0 on the bottom. Okay, so we can't do that. 1 minus sine x over cosine x over sine x minus cosine x. Multiply top and bottom by cosine x. So limit x approaches pi over 4. Cosine x times sine x minus cosine x. This comes out to be cosine x minus sine x. And these two cancel, leaving me with a -1. We've seen that before. I'll have to go back up. Cosine x minus sine x divided by sine x minus cosine x, that's -1. So I'm going to write -1 over cosine x. Okay. Equals limit x approaches pi over 4, -1 over cosine x. Now I can plug in cosine at 45 degrees, radical 2 over 2, so -2 over radical 2, or negative radical 2. So the answer is negative radical 2, looks like. Okay, let's see. 3.5. 3.523. Okay. Yeah, that was the only one problem where you have a role reversal between x and y. Regard y as independent variable, x is dependent variable. X is a function of y, and find dx, dy. So you just reverse everything that I taught you about dy, dx for this one problem. Okay. So x to the 4th y squared minus x cubed y plus 2xy cubed. Okay, so that means this time, whenever there's a y, you leave it alone. But when you see an x, you have to do dx, dy, which is exactly reverse in your brain of what happened when you saw x and y, you needed dy, dx. Okay, and since I have to do a product rule, I always like to recommend this plus negative. So I don't have to worry about distributing a negative anywhere. So the first function is negative x cubed and the second is y. Okay, product rule. First times derivative of the second, 2y, and don't need anything else, plus second times the derivative of the first, 4x cubed dx dy, plus negative x cubed times derivative of y, which is 1, plus the second y times negative 3x squared dx dy, plus second function, 2x times the derivative of y cubed is 3y squared, plus second function times the derivative of first, derivative of 2x is 2 times dx dy, and that equals 0. Okay, so it's a complete role reversal. Anytime you have a y and you're differentiating, leave it alone. Anytime you see an x, you need a dx dy. Now it's all the same as usual. Everything that does not have a dx dy goes on the other side. That one, making a big assumption I didn't make any mistakes. So these three go on the other side. And that one, and that one all have dx dy. I will factor out the dx dy. And that's going to be 4x cubed y squared. That one is minus 3x squared y. And 2y cubed. Then all three of these will change sign as they go over. So that one is going to become a positive. That one is going to become a negative. And that one becomes a negative. Okay. Okay, then just divide both sides by that. Dx dy is x cubed minus 2x to the fourth y minus 6xy squared all over 4x cubed y squared minus 3x squared y plus 2y cubed. Okay. Okay, 3.521. I don't recall if I did that before or not, but I don't remember, so I'll go ahead with it. F of x, oops, not equals, f of x plus x squared, f of x cubed equals 0. F of 1 equals 2. Find f prime of 1. Okay, so differentiate implicitly f prime of x plus, this looks like a product rule, first times derivative of the second, 3 f of x squared times f prime of x plus second times derivative of the first equals the derivative of the right side, which is 0. Differentiate with respect to x, f prime, product rule, first times derivative of the second, 3 times f of x squared times f prime of x, second times derivative of the first. Okay, now I plug in 1 everywhere. F prime of 1 equals 1 squared times 3 times f of 1 squared, f prime of 1 plus f of 1 cubed times 2 times 1 equals 0. Not equals, why do we keep putting equals? Plus. Okay, f prime of 1, they told us was, oh, no, they didn't tell us that. We have to figure it out. But f of 1 they told me was 2. Okay, so f prime of 1 plus 3 times f of 1 is 2, so times 2 squared, f prime of 1 plus f of 1 is 2 cubed times 2 times 1 equals 0. F prime of 1 plus 12 f prime of 1 plus 8 times 2 is 16 equals 0. That gives me 13. 13 f prime of 1 equals negative 16. So f prime of 1 is negative 16 over 13. Okay. And let's see. Okay, 25. Y sine 2x equals x cosine 2y pi over 2 pi over 4. Write the equation on the tangent line. Okay, so differentiate implicitly, product rule, product rule. So first times derivative of the second, derivative of sine 2x is cosine 2x times 2 plus second function sine of 2x times derivative of the first, derivative of y is 1 dy dx. Right side, first times derivative of the second, x times negative sine 2y times 2 dy dx plus second times derivative of the first, cosine 2y times 1, so I don't have to write it. Okay, now I'll plug in. So all the y's get pi over 4. Pi over 4, pi over 4. All the x's get pi over 2. Pi over 2, pi over 2, pi over 2. Yeah. Okay, if I multiply by pi over 2, I'm taking the cosine of pi, which is negative 1. So negative pi over 4. Okay, 2 times pi over 2 is pi, cosine of pi is negative 1, right? Plus sine of 2 times pi over 2 is pi. Sine of pi is 0. I like that. Equals pi over 2 negative sine of pi over 2. 2 times pi over 4 is pi over 2. That's 1. dy dx. Oh, I forgot. Let's see. What did I do? I did that. I did that. I forgot the 2. Right. Okay, so times 2. Plus cosine pi over 2 is 0. And that 2 cancels that 2. So negative pi over 4 equals negative pi dy dx. Multiply both sides by negative 1 over pi. Negative 1 over pi. Cancel, cancel. Pi's cancel. Dy dx is 1/4. Okay, point slope. So y minus y1 equals m times x minus x1. And I'll just stop there. '51, '54. Okay. Same section. '51, y equals inverse sine of 2x plus 1. So inverse sine goes 1 over radical 1 minus this thing squared. So 2x plus 1 squared. And then times the derivative of the inside, which is 2. That's essentially it. I mean, on the test, you would probably multiply that out because the 1's cancel out, I think. Yeah, there's going to be a 1, 1 minus 1, so it's 0. So it's not quite done, but you know how to do it. I'll just say etc. 54. Y equals inverse tangent x minus radical 1 minus x squared. 1 over 1 plus this thing squared. And then by the chain rule, I differentiate the inside. So it's 1 minus 1/2, 1 minus x squared to the negative 1/2 times negative 2x. And yeah, that's pretty much about it. I would cancel the 2's, but not much more. Okay, so that's all I want to do for that one, I guess. Okay, let's see. 3.3, 7. number 7. Y equals c cosine of t plus t squared sine t. Okay, you have to pretend c is a constant. The only variable is t. So derivative of cosine is negative sine, so negative c sine t. This one's a product. First times derivative of the second plus, whoops, second times derivative of the first, 2t. That's it. Yeah, you can put the 2t in front, but I won't take up class time for that. 21, equation of the tangent line. Y equals sine x plus cosine x. 0, 1. Find the equation of the tangent line. Okay, so y prime is cosine x minus sine x. Plug in 0. Cosine of 0 is 1. Minus sine of 0 is 0. So 1. Point slope. Y minus y1 equals m times x minus x1. Okay, so that's that. Okay, 3.819. 3.819. Right. Okay. So P of t equals P0 e to the k times h. P for pressure. This time instead of t, it's h. Okay. They tell us the starting pressure at sea level is 101.3. So P of t is 101.3 e to the kh. Okay, and when h is 1,000, the pressure is 87.14 kilopascals. So 87.14 equals 101.3 e to the k times 1,000. Divide by 101.3, 101.3 e to the 1,000 k equals 87.14 over 101.3. Take the natural log. ln cancels out. 1,000 k equals ln 87.14 over 101.3. Divide by 1,000. K is ln 87.14 over 101.3 divided by 1,000. Squiggly equal. Find my calculator here quickly. Natural log parentheses 87.14 divided by 101.3 divided by 1,000. So negative 0.0001557. Squeeze that in here. So P of t is equal to 101.3 e to the negative 0.0015057t. Just copy that thing. Okay, and to save time, I won't go any farther, but now you just plug in. So A, plug in 3,000. Oh, sorry, not T, it's H. Negative 0.0001557H is what that should be. I can't read it. All right, then plug in 3,000, and part B, plug in 6187. Okay, so that's as much as I feel like doing for that one. 3.9, 29, and 15. 3.9, I don't think you had to do 15. Yeah, 3.9, there is no 15, so I won't have to do that. Okay, I think I'm done with this sheet. 3.929. Okay, I think I already did that, but I'm going to do it again. It's the gravel one. So they do show you a picture. Okay, so volume is 1/3 pi r squared h. That's the formula. And the diameter was equal to the height. So diameter is 2 times the radius. So r is h over 2. So volume is 1/3 pi r squared h. R is h over 2. So 1/3 pi times h squared over 4 times h, which is 1/12 pi h cubed. That's v. Okay, so dv dt is 3 times 1/12 is 1/4. Right, it's pi over 4 h squared dh dt. Now you just plug in stuff. Okay, pi was 10 feet high. Put a 10 right there. Gravel is being dumped at 30 cubic feet per minute. So 30 goes here. And how fast is the height of the pile increasing? How fast is the height of the pile increasing? That's dh dt. Okay, that's what we're trying to solve for. So 30 is equal to 10 squared is 100. 100 divided by 4 is 25. Pi dh dt. Divide both sides by 25 pi. dh dt is 30 over 25 pi, which is 6 over 5 pi. And let's see, height per time. So that's going to be feet per minute. Okay. 3.10, 15a. Three point 10, 15a. Y equals e to the x over 10. It says x over 10. I'm going to treat it as 1/10 x. X equals 0. Dx equals 0.1. I might as well just go with it. I'll do a and b. So dy is the derivative times dx. So either 1/10 x times 1/10 dx. Now I just plug in. Put a 0 here and a 0.1 here. So it's 1/10 e to the 0, which is 1, times 0.1, so 0.01. Okay, so that's 15a, 7. Okay, I think we did that before also. I think I'm almost done. Ln 1 plus x is approximately x. Pretend you don't see that. Pretend you don't see that. X is the back of the book. And so I plug in 0, I get 1. No, sorry, I get 0. I plug in 0, I get ln 1, which is 0. Y prime is 1 over 1 plus x. Plug in 0 and you get 1. That's my slope. Okay, so y minus y1 equals m times x minus x1, or y equals L of x is equal to x. Okay, paper seems to curl on me a little bit here for some reason. Hold that down. Yeah, you should be able to see the recording. Okay, 27, e to the 0.1. Okay, approximate using a linear approximation. So f of x equals e to the x. The nice nearby number is 0. A equals 0. So the point is 0, comma 1. Derivative is also e to the x. The derivative is 1. So y minus y1, y minus 1 equals m1, x minus 0, or y equals x plus 1 equals L of x. So if I want an approximation of e to the 0.1, I just plug in here. So e to the 0.1 is approximately L of 0.1, which means I just plug in 0.1 here. 0.1 plus 1, which is 1.1. Okay, so 1.1, just for seeing how accurate that is. The actual value is 1.10517, something like that. 1.10517. Okay, so correct to the 10th place, 100th place. So it isn't until the 1000th place you get divergence. They're different. Okay, I think I've caught up with the chat the first round. So let me stop the share, check back the chat. Okay, let's see. So I think Prasanna may have helped me with that one. Is that a 1 in front of 0, 1? or 0.1. That was an L, I think, if that's what you meant. Let me show that to you quickly here. Sorry, there's no fast way to do this. Talking about this, that's L of 0.1, the linearization function. Linearization. L of 0.1 is a function, the linear function. 0.1 plus 1. Okay, and let's see. Irina, I'm not sure if you're good. I think Prasanna gave you how to do that, but if that's not good enough, I'll go ahead with that. And by the way, Prasanna, if you wouldn't mind, if you want to go ahead and put again on the chat, if you were going to have a review session after this, I don't remember if you did or not. But let me see, 3.437. Three point 437. I think I have time for that. 3.437. Y equals cotangent squared. All right. Okay. So Prasanna got it, but I'll write it in symbols because I know you can't do that there. So. Okay. Okay, so the outermost function is the squaring function. Okay, it's blah, blah, blah squared essentially. So the outside function is squaring. So 2 cotangent sine theta to the first power times the derivative of the inside function, which is now cotangent. So how do I differentiate cotangent? Negative cosecant squared of sine theta times the derivative of the inside function, derivative of sine theta is cosine theta. And yeah, that's basically it. Put the minus sign over there, maybe that's about it. Negative 2. And then I don't see any reason to change anything else much. Maybe put the cosine in front. You want the easier functions before the more complicated functions. So negative 2 cosine theta, and then copy that stuff and copy that stuff. So cotangent of sine theta, and then times cosecant squared of sine theta, negative 2 cosine theta, cotangent sine theta, cosecant squared. Yeah, okay. So I think that's it for 3.437. All right. And let's see, I think I'm caught up with the chat. Okay, and thank you, Prasanna. So Prasanna sent everybody an email. You have a review from 4 to 6 today, if anybody wants to go to that. Okay, so 3 minutes left. Anything else, please? Otherwise, we're done. All right, so have a good afternoon. You can start, if you want to start sending the homework even now, you may. I'll go ahead and take it. But the limit for the homework is what, 1:30 tomorrow? Okay. All right, everybody, so I'll see you all for the test tomorrow. Okay, have a good afternoon. Bye.